All right, so today we're going to take a look at this thing called concavity. Concavity is really just the way that the graph is curving. So it's either curving up or it's curving down. So we look at our graphs that are concave upward. So you'll see that over here to the left. You see kind of like that positive curve shape. And then we have concave down, right? So up facing down. Now, a little thing to help you guys remember what's concave up, what's concave down is this little saying right here. Concave up looks like a cup, concave down looks like a frown, right? So basically, happy face, cup, sad face, frown, right? Concave down. So again, concave up looks like a cup, concave down looks like a frown. Let's take a look at how we identify concavity. And really, when we identify concavity, we need to be looking at the second derivative. So the key for us is double derivative. So we have this this function here, f of x is equal to x cubed minus 6x squared plus 12x minus 6. The first thing we're going to do is find the derivative. So we got to find f prime of x, which is 3x squared minus 12x plus 12. Then after that, we need our second derivative. So last week we were taking a look at our increasing and decreasing functions. This week we're going to be looking at the concavity. And again, we identify concavity with our second derivative. Our second derivative here is going to be 6x minus 12. Now, just like last week when we were looking at our increasing, decreasing functions, we wanted to find those critical points for the first derivative. We want to do the same thing here, find any critical points for that second derivative. So we're going to take that second derivative and set it equal to 0. So we have 6x minus 12 equals 0. So 6x equals 12, and x is equal to 2. So we know that we have a critical point where x is equal to 2. So we're going to just put that on the number line, and we're going to do the test cases just like we did last week. With our values to the left and values to the right. Now you guys might have multiple test cases. You might only have one, multiple critical points as well, or just one, or maybe even none. That'll just help you decide what your answer is going to look like. So when we test, I'm going to test 0 over here to the left, and then let's test 4 over here to the right. So when I substitute into our double derivative, f double prime of 0, we end up with negative 12. We get a negative number. Negative number means our concavity is concave down. So at that point of the graph, it should look like a frown. And then over here, when we take a look at f double prime of 4, right, we test that point. We'll put you guys, again, just substitute it in. You could use the table in the calculator, whatever you want. In this case, I get positive 12. So since that's a positive value, that means we're concave up, right? It looks like a cup. So what we're noticing is on the graph here, for these values that are to the left of 2, and continuing on, we have a downward concavity. And then for these values to the right of 2 and continuing past, we have a upward concavity. So if we were to write the intervals, we would say we are concave down. Right? So, oops, let me erase that. We are concave down for everything left of 2. So that's going to be negative infinity to 2 with the open interval, and we are concave up from 2 to positive infinity, so everything past that. So that's all I'm going to ask you guys to take a look at today is identifying where we're concave up, where we're concave down, and just writing the interval of the domain that is concave up or concave down.